Aloha, Rich Alverson. This is ITS128, and in this video I'm going to cover Chapter 3. So I'm sharing my screen, and this is where we are in the syllabus, and that's what I'm going to cover today. So if we go over to the textbook, we can see that Chapter 3 types. Now these are, we know of integers, and we know floating point numbers, and they're kind of different, but they both represent numbers. And then there's strings, and then there's these other things. There's lists, and there's tuples, and there's sets, and there's dictionaries. And so in this chapter, we're just going to have a brief overview of these different types, so you get an idea of what they are. And then in later chapters, we're going to be manipulating them a lot more. So let's start with section 3.1, and so I'm in presentation view here. I'm going to see if this works. I want to go in. This is the regular textbook view, and so I'm going to present from the left side, and you can read the right side if there's something that's not clear. So we're going to start off by talking about strings, and strings are just a sequence of characters, to make words or names, and they can be spaces and digits, but in a string they're just digits and not valid numbers that can be added and subtracted. And to define a string, you just use these quotes. You can use single quotes or you can use double quotes, but you have to be consistent. And a string is a sequence type, as they say in Python, and that means that there's an index. There's a first character, there's a second one, there's a third one, there's a fourth one, and the order of them counts. It matters. In other kinds of types, the order does not matter. But in a string, of course, the orders matter. The order matters because, and so their strings, of course, are used for words and names and so on. And so here we're gonna in this little exercise here, I didn't realize the importance of this, but this Mad Libs example comes up a lot throughout the textbook, and here's an example of it's a game where first we ask the user to enter a type of relative, like a cousin or a brother or whatever, and then some type of food like enchilada or beans or whatever, and then an adjective, and like weight or something, and then over a period of time. So what this does is, by entering these words, then it's going to create some dumb story. So if we run this, so we can say, brother, and we can say type of food. My brother used to like, I don't know, baked beans, and enter an adjective. I guess you have to know what that is. Will make me more strong over a period of 1 year. And it says, my brother says eating baked beans will make me strong, so now I eat them every 1 year. Oh, I guess it should have been every day or every whatever. Okay, so anyway, so here we've done, we've just printed this out, and it just shows how, how string types are used. And I'm sort of showing you how these little things work. Here we're supposed to order the lines of code to generate the same story. So this is the output here, this part here, from here down to here, and that's what we see here. And now we're supposed to put these in the place. So it'll execute the program correctly. And it turns out that all we need to do is put all of these statements above this first print statement. It doesn't matter really the order after that. So if we go here and see this one here is not a valid statement. This is not a valid statement because cousin has to have quotes around it. So I'm going to put that one over there, and this is not a valid statement because it's got to have quotes around it. So I'm going to use this one, and the period is the day. So as long as they're above, then it works. I'm going to try making an error here. I'm going to try putting this over here and see what happens. Oh, okay, so what happened is it executed, and as soon as the gate got to this third line, it said that's an error because it's taking the word cousin as a variable, not as a literal, and the variable cousin hasn't been defined yet, so you can't have it on the right side of an equal sign because it hasn't been defined yet. And so that's an error, and then it stopped. It didn't go any further, and that's why the expected output is a bunch of this other stuff which never even occurred. So anyway, yes, that's wrong. It should really be this one. And then it doesn't matter where we put it, but if we execute it, then we should get the points. Anyway, so there's some strings, there's some methods, so-called methods or functions that we can use when we have a string type, and one of them is len parentheses end parentheses, and that gives us the length, the number of characters. So here we're using the len function to see the number of characters in this first variable, which is this first one, the number of characters in the second one. If we want to start this and play this, this one prints out that, and it takes that, figures out the number of characters, and then prints out that. And then the next one takes Gandhi, 26 characters, and then that's what that says, and then this one says JFK is. And what we're supposed to see here is that, it's not the length of the size of the variable name, it's the length of the value of the variable. See, so George underscore V is the name of the variable, but the value of its name and the value is this thing over here, and when we're using the len function, that's what we're interested in. Anyway, so okay, so we can refer to single characters by using this brackets thing at the end. So like, let's say we have a variable called alphabet, and then that's what it is. And then we can identify different, we can output different characters within that string using the brackets to reference the index. Okay. So that's pretty interesting. The minus sign means we're starting from this side and going that way. And if it's a positive number, it starts from this side and goes that way. So anyway, when you update a string variable, you can't. Does it talk about mutability? Let's see. The length function, indexing brackets, and changing string variables. Strings are immutable. So where is that on this side? Concatenation. Brackets. So I think it was up higher. Okay, so strings are immutable. What that means is once you've defined a string variable, you can't change it. You can, if 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 it's on the if the name of the variable is on the left side and you're assigning a value to it, then basically you're getting rid of the old one and you're assigning it a new value. But you can't just go in and change. You can't just go in and change one of the characters. In other words, you can't use this brackets thing to say alphabet of 0 equals C. This and because if you do that, you're trying to change this string inside, and it's immutable, which means it can't be mutated, which means once that's it, then that's it. So, and that's useful in a lot of ways, and we'll see that later. In fact, we'll see that later in this chapter. So in other words, this is an invalid way to update a character inside the string. All right, concatenating strings. You just use the plus sign to you have a string here and you want to concatenate York on the end of new. You just use a plus sign. By the way, there's no space here, so it's just gonna make new right. It's gonna go like this. If you wanted a space there, you'd want to say new plus space plus York. Anyway, or we put the space there. So these are very interesting things to go through. Okay, so concatenation. Here we talk about that. Here's another one of these dragging things. Let's do a couple of these. Let's type the program's output. Well, VINCENT, enter. Yeah. Oh. Red, enter. All right. I got a phone call there. All right, so let's do the next one. So here we're just, okay, so here we have redefined person. So this is just going to be TIFA, enter, and this first one is gone forever. See. And this here, we're going to print out the length of Vincent. So the length of Vincent is 1, 2, 3, 4, 5, 6, 7, because there's 7 characters in Vincent. So that's what we're printing, 7. And here we're printing the 0th character of whatever that is. And what that is this. It's capital C, lowercase I, lowercase d. So what's the 0th character? Well, the 0th character is the capital C. All right. Let's just finish this off here. Okay, so what's the -2 character? I don't know. Okay, so -1, I guess, would be the A. Yeah. And -F would, I know, -1 would be the A, and so -2, I'm guessing, is the F. I don't use this at all, but what you do is just try it. Is it right? Ah, good. Alrighty, what's the last one? Oh, so here we're using this concatenation. So it looks like we're taking person 1 and we're concatenating it with person 2, and that's going to give us person 3, and there's no space or anything, so it's going to be Barrett, Tifa, enter. All right, so I got all the points. Okay, so you should be able to do those. Read strings this and this from input and assign a variable action with and what? Let me see what this is. Oh, assign this action with that. Okay. Oh, got it. Okay, got it. Okay, let's just see what this is. Okay, read strings. Read those two strings. Okay, so I'm gonna go. My name equals input, and then I'm gonna say location name equals input, and then I'm gonna say action equals went to. Okay, so it's going to print out Joe went to Waikiki or something like that. All right. Okay. Very good. Let's do the next one. Read this from input and output this. Ah, okay. So I'm going to read this. Okay, so I'll read from input. Okay, so let's do that. Fave drink equals input. Okay, that's this part. And then I have to output the following, all separated by spaces. Okay, well that just means I can use the print thingy. So I can say, print the drink, comma, fab drink, comma, consists of, comma, the length of fab drink, followed by characters. And that. Okay. Yeah, right. I know that. All right, so let's see what this gets me. Oops, oh, look at that. Oh, and what's the error? It's good to see what these errors are. That. It says name error. That is not defined. Did you mean this? Ah, he's pretty smart. Yes, that is actually what I meant. Yeah, so I'm gonna fix that. I'm just gonna go. I assume it lets me fix it. I'll just take out that G there and check it again. All right, there I got that one. All right, so what's next? Read that and output. Oh, so I have to output the first character, and then I have to output what it is. The first character of that is that. Okay, so it's basically, let's see, print. I'm going to be real fancy here. I'm going to see if this fanciness works. It should work. All right. I'm going to put this here, and then I'm going to put input Oh, no, I can't do it. I have to have a variable. I have to actually do it separately because I have to name it as a variable because I have to reference it twice. So I got to do this. I was going to try to be fancy. Okay, yeah, and then I got to put fab fruit here. Uh, is fab. Yeah, I got to reference it. Fruit. Oh, I got to put a comma and then fab fruit, referencing the first character, which is index 0. That's right. All right. What's the last one? Okay, a first character. Wait, did I press this? Did I press the wrong one? Okay, here we go. Okay. Read that and that. Read that and that. And then assign this. Okay, let's see if this works. Okay, I'm going to be fancy now. All right, first of all, let me copy this. Paste. Equals quote input plus likes, space likes space likes space plus input. Okay, I'm going to see if that works. All right, let's see if this works. Ooh, look at that. It works. Of course, what they wanted you to do was to define a variable called student name and set that equal to the first input, and then define another variable called course name and set that equal to the second input, and then you can concatenate up like that. But I just did a shortcut there and I bypassed creating these variables. Anyway, all right, list. Okay, so that was strings. Okay, so let's go on to list basics. What's going on over here? All right, list basics. So a list is like a string, except for with a string, it's just a list of characters in order. But with a list, it's a list of elements in order. And the elements can be characters, but they can be more than characters. They can be numbers, they can be strings, they can even be other things, lists. It's just a list, an ordered list of things, and they can be, it's heterogeneous. It doesn't have to be the same type of thing. If it's a list of, I mean, all of the elements in the list don't have to be of the same type. So we define this concept called a container because we're going to use that concept in other things. But a container is a group of related values, and And so a list is simply a container surrounded. It's a container surrounded by sequence. A list is a container. Okay, so we're defining a list. It's a container created by surrounding a sequence of variables or literals with brackets. Okay, what if I can make this? I guess not. All right. And then an element. This is terminology. An item in the list is called an element. So here we're defining a list called prices, and so we have the brackets thing, and then the first one is going to be this thing, which is a string, a 3-character string starting with a $sign, and a 2 and a 0, and then the value $14.99, probably $14.99, and then some integer value which is 5. Okay, so that's 3 different types. So this is how you would represent it inside the computer. And so here we're defining, first we define these variables with these values. And then we are, here, I'm just like this. We do that one, do that one, do that one. And then we define a list called prices, and we can use the brackets, and then inside here we can put these variable names, which represents these numbers. And so really there's numbers in here, not the names. And then here we're just printing out this is the name of the list. Here we're indexing elements in the list. So the 0th element in the list is this value. It's this value. The second element in the list, which is this index 1, is going to be this value, and the third element in the list, which is index 2, is going to be this value. Thanks. We're building up something down here, and then so this is defining the list. It looks like that, and so there. And we can change these variables. We can change this variable. It's not going to change this. We can change this value here. It's not going to change this. We can change these values because lists are mutable. Strings are not mutable. Once a string is made, if you want to change the string, you have to make a whole new one. Lists, you can go in there and surgically change things, you know. So, and then there's some methods. Some of the string methods are quizzes are over here. Okay, there's some of the string methods are append, and what that does is that appends a new element onto the list. So what goes inside here is an element, and then that gets appended onto the list, and the notation looks like this. So you have this list here, and it's got those two things in it, and then it appends ABC onto the list. So then it becomes 3 things. See, so that's how append works. You know, we append it onto my list, and then my list now has 3 things on it. And this inside here is an element. It's not another list. Okay, pop will remove. This is an index that goes inside pop. It's an index, so it's an integer. It's going to be an integer. Remove, for remove, it's same idea, except for it's a value that goes inside there. So here we're going to remove the value. So it goes and finds that value, and if it doesn't have that value, it's going to say error. Here we're finding here is remove the second element, and if it doesn't have a second element, then it returns an error. Okay, so here are some things that we can do. This outputs, of course, just like a string, outputs the length of the list. This outputs or this concatenates. This would be on the right side of an equal sign. This concatenates this list onto the end of this list. So it's kind of like append, except for this is a list that you're appending. This is going to find the element in the list with the smallest value, but in this case, all elements have to be of the same type. A lot of lists are that way. This is going to find the one with the highest value. This is going to add up everything, and these have to be all the elements have to be numbers, so they can be added. And then this is going to return the index of the first element with that value. And this is going to count the number of elements with that value. So these are some handy list methods. And of course, just like, these go dot. What do I say? Oh no, this is a list inside here. And then these are methods that you invoke by using this dot notation. All right. So let's do one of these here. All right. What is the value of the length of user ages? 1, 2, 3, 4, 5, 6, 7. Right. What's the next one? What expression changes user ages? Oh, well, let's look at the choices. Remove 66 or pop 2. It would be this, pop 2. Because remove would be removing a value, and none of these would work. Because there's no 0 in there, there's no 1, and there's no 2 in there. We use pop because the index is there. And it's the, oh no, we want to remove the middle one, don't we? We want to remove the 55. So that's index 0, index 1, index 2. That's index 2, no, index 1 we want to remove. So that's this one. It's that one. That's the one we want to pop off. Yeah, there we go. All right, what's next? Got this and that, and what expression creates that? So first we have, this looks an awfully lot like user ages 2, and this looks just like user ages 1. So I bet it's user ages 2 plus user ages 1. This one, user ages 2 plus it appends the whole list. All right, what's next? What is returned by user ages that? So it's index number 2, which is the third element, which is index number 2 is 0, 1, 2 is a 1. It would return 1. Wait a minute. Oh yes, no, it wouldn't. What is it? What are the choices? It would be an error because this is index 2 would return the index of the value 2, and there's no 2 in there, so it would return an error. That's what I think. Yeah. Index 2 returns the first index location of 2 in the list. It doesn't have a 2, so it's an error. All right, what's the last one? What is the value of the sum of user ages? Well, they're all the same type, and they're all summable. They're all numbers, so you can sum them. And so this adds them all up. So 6 plus 2 is 8, plus 5 is 13. Yeah. All right. Well, what's this one? A patient's name, temperature, and age are read from input into variables, this one, and to this one. Create a list of this called this, which holds this one, and this one. So we have to create a list called called this equals bracket patient name comma, put a space there if you want to, patient temp comma, that's right, name, temp, age. Well, I could have done this. Copy. Close that and change and get rid of this. There, how's that? Name, temp, and age. All right, let's see if this works. Yeah, okay. All right, what's next? Okay. 2 ages read from input. Then this is created with 2 names read from input. On one line, I'll put the name list's second element, and then I'll put that. Oops. And then I'll put that, and then I'll put years. The age list's first element, the name's second element, and the age list's first element. Oh, that's kind of weird. I don't know why they do it that way. So anyway, I need to write some code, and I need to print. Am I going here? Yeah, print. I don't think I can afford spaces. Print names list second element, names list second element, which would be 1. And then I'm going to concatenate that with this. Right there, because it's kind of tricky really what that is, because really it's got a double quote followed by a single quote, okay, plus, because I'm concatenating, age lists first element. Age is, put a space there, list the first element, which is index 0, plus years. Close the parentheses. Well, that's kind of a weird thing to do, but on one line, I'll put that. Okay, let's see if this works. Yeah, great, wonderful, wonderful. Okay, what's next? Data list is created with the first 4 integers read from input. Okay, so we're reading one input, then another input, then another input, then another input. And before you know it, we're converting all of these inputs into actual integer values. You know, when you just use input, they come in as a string of characters, and we use this int function that only works if those string of characters looks like an integer. And so that it converts that, and then because we have brackets here, it is it's making it a list, and so that's going to be a list. And so what are we supposed to do? Remove the third element, then read an additional integer from input and append. Okay, so all right, first I'll remove the third element. Data list remove, oh, remove, I can use pop, right? Pop, yes. Here we go, this one over here. Pop. Pop, remove the third element. Well, that'd be index 2. Okay, first I'm going to do that. And then I'm going to read an additional integer from input and append that. Append the integer to data list. You know, okay, so I'm going to see if this works. I'm just going to do this. Append, see if this works. Int, input. Okay, let's see if that works. So, you know, operator precedence, it should do it the most inside thing. First it's going to do that. Then it's going to append whatever that was onto whatever this is, but this is, well, let's see if this works. I don't think it did. Oh, it was never closed. It's never closed? Wait, it was never closed. The append was never closed. Oh, yeah, oh. I always do that. I always forget. All right, let's try it again. All right, let's quit being fancy. First I'm gonna do this. Then I'm going to read in something. Read in a additional integer equals input equals int input, and then I'm going to do data list append additional integer. Okay, because my thinking might not be quite right. Oh yeah, okay, there we go. All right. Okay, anyway, let's do the last one. Is created with the first two integers read from input. There we go. And then this is created with the last two integers. Those two. Create a list called that, which concatenates this at the end to the end of this. Then assign a variable called located index with the index of the element 5 in data list 3. Okay, so I'm supposed to make a data list 3 paste equals this to the end of that. Okay, and then assign a variable called located index equal to the index of the element 5. Okay. Data list 3 dot index 5. This, using this, find the index. The index, okay, does this work? I guess it works. Okay, all right, what's next? Tuples. Tuple of honey. Okay, so a tuple, pronounced tuple or tuple. Tuple or tuple. Okay. You know what I think about how you should pronounce this? How you think you should pronounce this the way you feel most comfortable pronouncing it, okay? All right, so personally I think I like tuple. So tuple stores a collection of data like a list, but it's immutable. It's immutable. And it's also it's like a list, so it's ordered. A list is ordered. But you can't change elements. Once the tuple is made, it's like a string. You can't change it. If you want to change the tuple, you got to get rid of the old one, make a new one, and assign that name equal to the new one. So tuple is useful for things like coordinates. Coordinates. And, okay, great. Tuple. Coordinates. Now there's a thing called a named tuple, and this is pretty cool. It's not anything like this that I know of in other languages, but I'm sure there is. First of all, you define, and it's kind of like a class. Okay, it's where you define. First of all, you define a named tuple, and you name it. And this the named tuple is going to have it's going to have the name of the car. Okay, in this case, you're naming it. Okay. So here we have we're defining a tuple, and the tuple is it's the name of the tuple is Chevy Blazer, and we define it using this named tuple construct that we defined earlier, and the first thing that's in there is going to be the make. Okay, the named. Okay. The make, which is this thing, the model, the price, the horsepower, and the seat. So the tuple is going to have this many elements in the tuple. 1, 2, 3, 4, 5. And this is going to be the name of the tuple. And I guess this has to be okay. Anyway, so that's how you do it. Let's try to I'm not used to making tuples. So let's go through some challenges here. A tuple named school data is created with 3 strings and 1 integer read from input as school data's fields. So we're going to read this, 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 and this. Output the school data's 4 fields in the same order that the fields are read. Let's see an example. The input is this, 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 and this, and the output is this, 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 and this. So we're defining the tuple, okay, because we can do a string. The fields may also be a single string with comma separated values afterwards. So this here it's defined as a list, but it could be just a string of that. Anyway, all right, and so this is how you print it. So I think the answer is print hold on. All right, so we're printing what's the name of the school data. We're doing all 1, 2, 3. Okay, just 0. Yeah, this is what we do. One, 2, 3. All right, and oh look, this one over here is different. Tuple named city info is created with 2 strings and 1 integer read from input. Blah blah, same thing. Oh, I gotta press start. Okay. Print city info 0. 1, 2. Did I get that one? Yeah, I guess I did. Yeah, I got it. Okay. Anyway, all right. Anyway, so so these are tuples. You can go through the rest of these. What's the next one? I did that. This one is 3 values are read from input and stored into variables. Initialize a tuple named that to store that, and that. Okay, so now this is an interesting one because let's see if I understand this right. I'm going to say person info equals named tuple no underscore. Person info. I guess this is what it is. Do it this way. First name. I guess I'll just do this. First name, last name, birthday. First name. Let's add some peanuts. Yeah, I don't think this is right. I think that I need to do this. Wait a minute. I think I need two statements here. I think I need one that I just had. And then I also need all right, so let's start over here with this challenge activity. A city is a named tuple with fields, name, state, and population. For these challenge activities, you have to make sure you distinguish between when they're asking for a named asking for, and we're talking about a named tuple versus just a regular old tuple that's not specifically named. So in this here we're talking about a named tuple. We have and so we have a named tuple defined city, and we've inputted three values that go into a tuple, which the variable name for the tuple is city info, and it is defined using a named tuple. So that means we can refer to the elements of the tuple using their names. That's the advantage of a named tuple. So instead of referring to it as index 0, index 1, index 2, we can refer to them as name, state, and population. So what we're supposed to do is output the following. First, the city name, followed by, okay, so let's start. So print city info dot name. I should do this first. I'm supposed to do this first. Copy plus. Okay, so that, and then also I'm going to be lazy here. State and population, and it's going to be state population. All right. So let's see if this is right. Now let's see an example. Okay. Oh. And what did I? My output was that. Okay, so I think I have to do something like this maybe. str. Yeah, that's better. Okay. Because when you print, you're printing a string. Oh, what I did, the problem was I tried to add an integer onto a string, and you can't do that. I got to convert it to a string first. You know how you use int to convert from a string to an integer? Well, you use str to convert an integer to a string. That's what that is. Okay, what's next? Let's see. Let's do this one over here. This one's a little different. A tuple named color is created using one string and three integers. Let me see if I can do this. This works. The output the colors for fields in the same order as their. Okay, so I think what does the example look like? Okay, so I think that this is just start it. Print color. Here we can just use indexes because it's not defined using a named tuple. It's just a regular plain old tuple with a defined variable name, but it's not a named tuple. Okay. First I'm going to print that, then I'm going to print, and then okay, I think that might be right. Yes, I got the points. Good. Okay, what's next over here? Oh, gotta go here, next level. Okay, here we have, okay, here, oh, we just have to define the tuple. Initialize a tuple named this, storing this, 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 and this. Well, that's just kind of what we had over here. Here we're just defining a tuple called person info. And I'm going to have it be equals, I think I used parentheses, right? And I'm going to do first name, last name, age, credit score. I think that might be all. Oh yeah, okay. Let's do this one over here. Next level. Okay, here we're doing 3 values are read from input and stored in variables, blah, 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 blah. Initialize a tuple, name city, does the same thing. This is easy. Okay, this is the same thing. City equal Siri. I don't know, how do you turn off your Siri? So I'm going to name a tuple, and I'm going to say city name, state located, population count. I think that might be all I need to do. All right, what's next over here? Okay, so here we have to define the named tuple. Here we have to define the named tuple. Okay, 'cause I was waiting for a hard one like this. Okay, so up here, first we got to say that collections thingy, whatever collections at the top. We got to say this first at the top. That's why I'm just gonna copy this. Similar to that. Copy. Put this down here. Right, that's where I am, right? Right here. And it's gonna be called person. Copy person. And it's gonna be first name. Oh, it's these names. These names. So that's what the names are. So it's going to be first name, last name, license plate, age, and we don't need this last one. Okay, very good. Okay, that's what I think. Is that right? Ah, goody deal. Good deal. Okay, what's this? Let's do this number 3 over here. Same thing. Same thing. We're just defining the thing again. So let's go to the next one. I can skip. Here we name it. No, here we're defining it. A school name tuple. It's a name tuple. Read 3 strings and 1 integer. And then create this. So read 3 strings and 1 integer. I think I just do it all in one line. School equals, how do I do this name tuple thing? School, I think I do input for the school name, input for the city, input for the state, and int input for the enrollment. Okay, I wonder if that's right. I think so. Yeah, I've got to read them in here. Yeah, all right, this work? It's never, oh, I never closed. See, I don't make that mistake. All right, so, okay, very good. Okay, one more, sets. Let's see, how far do we go here? Sets and then, okay, so, all right, I'm gonna close it up here, and I'll start a new video starting with section 3.4 with sets. All right. Thanks for watching.